The children, in this question, 3 vectors are shown: OA, OB, OC, and it is asked to calculate the resultant of these 3 vectors. It is a very simple and easy. So let us solve this. Children, first look at here. So our idea is that first let us neglect B. Neglect means we are not going to completely remove. It's not that actually. So first let us consider OC vector, OA vector. So here is OC vector is drawn with the magnitude R, OA vector is drawn. Children, let us recall once again parallelogram of law of vector addition. And here these 2 vectors are representing the 2 adjacent sides of a parallelogram. Then the resultant vector is along the diagonal. Here let us consider here S is the resultant vector of vector OA and vector OC. As per the parallelogram of law of vector addition, children, square root of p square plus q square plus 2pq cos theta. Here you make it out, sir. What is p? P is not at all given. Wait just. So here p is, children, yes, it is a vector OC magnitude, that is R only. And here q is what, children? Here vector OA magnitude, it is R only. Anyhow, if you can see, the angle between the 2 vectors is how much, children? 90 degrees. And here cos 90 is going to be 0. So this entire term will be 0. Okay, fine. So here the S is equal to, S is, children, S is what? The resultant, the magnitude of the resultant of the vector OA and OC. That you should keep in mind. So it is going to be, so in the place of P, R square plus R square. This entire term will be 0 because theta is 90 degrees, cos 90 is 0. So this will be square root of 2R square. This will be root 2R. So children, this is a magnitude. This is a magnitude of the resultant vector of the OA and OC. Now you make it one doubt, sir. What about OB? I am going to that only. If you can see, children, so that's what I am telling. So according to the parallelogram law of vector addition, this resultant vector is along the diagonal to this OA and OC. Now you can see this OB also along the diagonal only because it is a 45 degrees. So what I mean to say that, children, look at here. So this is OB vector. So this OB is nothing but the radius of the circle. So definitely it's a magnitude also R only. Now whatever the resultant vector of OA, OC which we got, also in this direction only, try to. So vector S and a vector B are in the same direction. So whenever 2 vectors are in the same direction, children, directly they can be added. So the resultant vector is equal to the resultant vector. So the magnitude of the resultant vector is equal to the magnitude of the vector B, that is OB, plus vector S. So OB is R and S is what, children? Root 2R. So capital R is equal to, you can take a smaller as a common, this will be 1 plus root 2. So children, this is the resultant of OA, OB, OC. Children, this is the resultant of OA and OC only. First we calculated the resultant of OA and OB, as this resultant is in the direction of OB and both are added. So we got the answer. Okay, children. Thank you.